So coming back, trying to take rectangular points and make them polar, just kind of think what quadrant you're in, and it will relate back to the appropriate quadrant for polar graphs, right? So if we look at this problem, right, I know that I'm in, this was our last problem from the previous part, but notice 1, 1 is in the first quadrant, and notice that we get 145, it's in the first quadrant. So again, we do need to use both of the equations to make sure that we are in the right place. Okay. So we can try another one, right? So if we do one more, so if I say negative root 2 comma root 2, again my theta is somewhere between 360 and 0 degrees. Doesn't matter about my r. So negative x and a positive y, I know I'm in the second quadrant. Okay. So when I'm looking at my r, so again I'm going to take that and I'll square it, and I'll take my y value and I'll square it. So those will go away. So it'll just be 2 plus 2. So r is equal to 4. So or sorry, r squared. Forgot the squared. So that means r is equal to the number 2. Okay. So when I look at my cosine, so x, so negative root 2 is equal to 2 cosine of theta divided by 2. Notice that for the cosine of theta is negative. So again, I'm either in quadrant 2 or 3. If I take my y value, so root 2 sine, so root 2 over 2 sine of theta. This again is either in quadrant 1 or 2. What do they have in common? Quadrant number 2. So quadrant number 2, the easiest one, would be my theta would be 135 degrees. So I put these two together. So 2 comma 135. And it kind of then just solidifies that this is also my second quadrant. This was also my second quadrant. Could I have made it with my r value negative? Of course. But again, I only needed 1 point to make this. Okay. One of the last things that we are going to kind of discuss is just kind of how do we change equations from polar to rectangular and vice versa. So for each rectangular equation, give its equivalent polar equation. Normally I have you guys sketch this, but we're not going to sketch our graphs. It's a little bit more challenging with distance learning. All right, so here's our first one. So x squared plus y squared is equal to 9. Okay, so hopefully you kind of recognize that this is a circle. All right, so this is a circle. If we didn't recognize that circle, not that big of a deal. But what do I know? I know that x squared plus y squared, all of this is equal to r squared. So I know that r squared is equal to 9. So r is equal to 3, where theta can be any value. So basically, I'm getting rid of what makes it rectangular. So basically, get rid of x and y. I did it. I got rid of it. So just r is equal to 3. All right, that was an easy one. Let's do a little bit more challenging one. So let's do part B. So what is about this one? So 3x minus 2y is equal to 6. So this one's a little bit more tricky because I don't just have an x squared and a y squared. So what I do want to know is that x is equal to r cosine of theta. So I can get rid of the x by replacing it with this. And I know y is equal to r sine of theta. So I'm going to replace this guy right there, and I'll replace this guy right there. So this will just be 3, and then r cosine of theta minus 2r sine of theta is equal to 6. When we're doing polar graphs, we want to solve for r, so solve for r. So let's distribute. So 3r cosine of theta minus 2r sine of theta is equal to 6. What do they both have in common? the r. So let's pull out the r. So 3 cosine of theta minus 2 sine of theta is equal to 6. So that's it. So r is equal to 6. And then 3 cosine of theta minus 2 sine of theta. That's essentially it. That's all we're that's all we're doing. Right? What happens if I want to change it? So let's go backwards. So let's go rectangular, or let's go to rectangular. So we're going to take polar equation to rectangular equation. So basically, get rid of r and theta. That's essentially it. All right, so my first one, so we'll call this a again. So r is equal to 2 cosine of theta. All right, so looking at this problem, so again, I know that x squared plus y squared is equal to r squared. I don't have an r squared. I know that x is equal to r cosine of theta, y is equal to r sine of theta. So I don't need this guy. In order to get rid of that, I need the r to move to the other side. But if I divide it by r, then the r will be in the denominator. I don't want it to be in the denominator. So how do I make an r just appear with the cosine? Well, I'm going to make it appear by multiplying both sides by r. So as long as I do it to both sides of the equation, it's legit. So this now becomes r squared, and then this becomes 2r cosine of theta. I've now gotten rid of r squared, so I now can replace it with x squared plus y squared, and now I can replace this guy with 2x. So let's just move it to the other side. So x squared plus y squared minus 2x is equal to 0. That's as far as that we're going to go. This is also an example of a circle. So this is also a circle example. But again, we're not worrying about it. All we're doing right now is just making sure the r and the cosine can go away. All right, so let's try another one. So r is equal to 4 cosine of theta minus 2 sine of theta. So go ahead, pause the video. Try to get rid of the r and the cosine of theta. Make your equation equal to 0, and that's as far as we have to worry about going. And I'll just put these here for reference. That way you guys can see that when you have the video paused. All right, so if you're coming back from a paused video, hopefully this is something that we've gotten. So again, a kind of similar situation. I don't have an r squared, so I can't replace that. These two are both missing the r's, so I'm going to do exactly what I did before. I'm going to multiply everything by r. So this will become r squared, 4r cosine of theta minus 2r sine of theta. So x squared plus y squared is equal to 4x minus 2y. Move everything over, so I'm just going to make the x's be with the x's and the y's be with the y's and call it a day. That's it. That's as far as we need to go. We've gotten rid of the x's, we've gotten rid of the, gotten rid of the cosines, gotten rid of the sines. All right, let's try one more for fun. So r is equal to 3 over 4 cosine of theta minus sine of theta. So again, x squared plus y squared is equal to r squared. X is equal to cosine of theta times r. And then y is equal to r sine of theta. So go ahead, pause the video, try your luck at this one and what you can do. All right, so if you're coming back from a paused video, I could possibly multiply this by a 1 over r, but then I'd have to multiply this side by a 1 over r, and that does cancel out my r's. Doable, but I think that this will just be easier. I'm going to cross multiply. So I'm going to multiply the 3 and the 1, and then the r with the denominator. So it'll just be r times 4 cosine of theta minus sine of theta is equal to 3. So 4r cosine of theta minus r sine of theta is equal to 3. R cosine of theta, there's your x, so 4x, and there's your y, minus y is equal to 3. Hopefully you recognize that this is a line, right? So I can move the y over to the other side. So this will actually just be y is equal to 4x minus 3. Not that we had to do that. As long as you got this far, that is fine. All right, so that's your polar equations and your polar coordinates and your rectangular equations, rectangular coordinates, kind of going back and forth. If you want to see kind of what else we could do with polar graphs, there are some fun graphs that we can do. That'll be in part 4, not required to watch, but it is a little fun so we can see kind of what's happening with our graphs.